Bryce. I'm the VP of Products at Univa, and just a little bit about Univa. I think we can advance it. Is this working?
It should be.
What?
Let's just do spacebar for a second.
Okay. It needs a little bit of,
Man, first presentation, we were just...
There we go. All right. So a little bit about the company. We've been around in workload management space for a long time, so that's really Grid Engine. I think a lot of you are probably familiar with Grid Engine, what it does. There's many other tools that do something similar. That's formed the core of our company for a long time, and you can sort of see from a general view of how many customers we have and how much our software runs on. That's just direct customers. We have a lot of indirect customers. And here, when it comes to integrated applications, really, it's kind of disingenuous. Like the marketing guys put that up there, but the simple fact is, if you can run your application on Linux or even Windows, you just stick a submission command in front of it, and it's pretty much integrated. So there's the level of difficulty to get something working in Grid Engine is super simple. Number of cores is actually over 3 million now, and jobs is over 7.5 million jobs per day. So that's like one cluster running that many jobs. It runs it pretty consistently day in, day out. And so we are predominantly a commercial company. We have offices in Toronto, Chicago, and Munich, and people spread out all over the world. There's people in Korea, there's some people in Japan, there's more people in the States. You could say somewhat a distributed company. A lot of smaller organizations are like that. It's going to have to do the space bar. All right. So where do we sell our software? We sell it across many different verticals. If I wanted to pick one where we sell the most, it would be life sciences. We have, I think 11 of the top 12 life science companies are running Univa Grid Engine. And the reason for that is, from Grid Engine, the history of Grid Engine, the open source, a lot of tools were just integrated with it. So it's a very easy transition. There's no real change from the command line. You just sort of swap out the open source one, stick in ours, and it works. It's not a big jump, but you can see it's used all over. So in very large clusters in oil and gas, in lots of government institutions, manufacturing. The one I like to talk about is the airlines, because if you arrived here today, you were probably scheduled by a small Grid Engine cluster, Univa Grid Engine cluster, because the fleet and crew management software, it runs a Grid Engine cluster. So every single one of the airlines has one of those. Still not advancing. Maybe I have to fix this one.
Go ahead, I'll work on this.
All right. And so we have two product lines. We have the one where I talked about, which is Grid Engine, but Grid Engine is not enough to actually put stuff into a cloud environment. And I'll talk a little bit about more this product in this presentation. Because what we're seeing is, a year to a year and a half ago, people started coming to us and saying, who are our customers, hey, cloud's interesting to us now, we want to figure out how we're going to get there. Whereas before that, it was not, don't talk to us. It looks too complicated, don't talk to us. It's not something we're looking at now. So we came out with NavOps to handle this hybrid cloud type migration. I'm going to try and advance here. Nope. All right. But, so why did we realize this was happening? Well, when people started coming to us, we said, okay, let's do a short survey. Let's reach out to our customers and ask them, okay, why is it now you think cloud is important? And how many of you are really interested in doing it? Now, in many ways, it's sort of, self-selecting, because, we're looking at our customer base, and they're running Grid Engine, and they already have clusters in on-premise, and then some of them are looking to cloud. So a lot of them said, 70% of them, in fact, said, we're interested in going to hybrid cloud. Which is pretty interesting, because previously when we looked at research, a lot of people are saying, no, everybody's going to cloud, they're not going to hybrid cloud. So it's a big shift. And, cloud only was only 30%, at least it adds up to 100 like it's supposed to. And 16% were already deployed or planning to deploy in HPC cloud. So there are people who are our customers and they're already doing it, they didn't tell us. We found out about a few of them. And quite a lot of them are open to moving to cloud. So, and we think the reasons for this are really changes within the organizations themselves and their level of comfort. I think that they're becoming more skilled in cloud infrastructure, so they understand better where it's best used. Also, I do think that they now begin to understand the economics of it, because if you use things like spot instances on AWS, or if you use the preemptible instances on Google, or if you use the low priority VMs on Azure, it's actually, from a money perspective, it's worth it. I mean, on AWS alone, it's about 80% to 90% cheaper using those spot instances. Yeah, it doesn't work? No. So some of the information we got out of that survey was what things are driving people to go to cloud, and it actually changes depending on the vertical we are talking to. For life sciences, they actually have large volumes of shared data, so putting some of that shared data in the cloud and then running stuff there made sense. A lot of it can be public data. They had less IT legacy, so they were more comfortable going to cloud. And they actually were seeing that the skills for operating their internal HPC infrastructure were diminishing, so less people doing it. So they needed more people to put stuff into cloud. In aerospace, it was really, I think people have talked about this a couple of times, they had internal projects, like the Rescale guys do a presentation where they talk about, Boeing had to do I think it was the wing for the Dreamliner, right? They just couldn't do it. So they went to cloud. And that's a good example where you can't wait for that, to be done. You've got to get it done. In education, people are focused on latest and greatest hardware, latest and greatest technology. And we have one of our use cases in here where someone talks about that in particular. One of our customers, where he says the reason why he went to cloud was that. And in EDA, it's about smaller EDA organizations. We have some of the biggest EDA organizations using our software, and they in particular are having a harder time going to cloud, but the smaller guys, much less legacy IT, they're moving. All right.
I'll get you new one.
Okay. Some more early adoption factors that are pointed out from that survey. I guess from our customers, and we spend most of our time focusing on AWS, and it's backed up with the results of our survey. We asked our customers, what are you using? You can see that a large chunk of them are already using AWS. And followed right behind it, not a little more than half, but is Azure, and we actually see that as well. So when we talk to people, that's what we see. And then the last one is Google. Oracle's quite far behind. If you're looking at, the Coke, Pepsi kind of thing, well, these guys are probably out of the picture at this point. So people who are adopting, they have object data volumes aren't too large, they have lots of open source applications, they want to create these self-serve clusters for their communities, they have preference for the abstraction of infrastructure versus buying a bunch of boxes. People have talked about it at AWS and other cloud vendors. You're not managing boxes anymore. You've got this, software infrastructure you're managing. And top-down organizational mandate is another one where we see in our customers, the CIO says, you must do this. You got to get it done. The top 3 application areas are here: HPC, AI, deep learning, and big data. This one is mostly containerized. Next. New clicker? Okay. And then we asked them, what are your decision criteria for moving? And then what is the resistance? I think the resistance ones are still most interesting, which is, the security of their data, right? Price performance, we always hear that. And I think it's because people haven't really looked at spot instances. They're thinking, I'm going to buy a bunch of reserved instances and run it forever. Honestly, if you do that, you're going to pay a lot of money. Probably too much money. Data gravity is another biggie. We talked about it with our EDA customers, and they were like, okay, sure, we can try and take one application and move that to the cloud. But then they said, okay, we need the following data set for that to happen. And then when they start pulling that data set, they realize that, oh, that's attached to, like half a petabyte of data. And so that causes issues of data gravity. And then lack of cloud expertise within the HPC teams. This is, I mean, we don't want to hear it, but it's pretty common. There's a lot of our customers inside the organization. There's two teams. There's the HPC team, or the technical compute team, doing IT type work, and then there's the cloud team. And I don't think they like talking to each other. It's like, it's shocking, because some of our POCs we've gone through, just to get, you know, the ports opened in the infrastructure to run simple things, would take a week. Because the HPC team would ask the cloud IT team, and they're like, yeah, we'll get around to it whenever. And slowly they open up those ports. Or even getting the proper permissions or the proper, you know, roles to run stuff in the cloud takes a long time. So I think we really have to break down those barriers, and those two teams have to be working much closer together. Otherwise, these things are just never going to work. And this one, I think you know why data egress is important. You take your half a petabyte of data, you stick it in the cloud, and then they charge you money to pull it back out. Usually customers are, frankly, can't get their head around that. They're just like, well, that was my data, and now you're charging me money. So, big issues there. All right, can you go to the next slide? Go to the next slide. This was if it was doing a demo, which I'm not doing. So one of the tools we use to create this environment, I'm switching over now to the product I've mentioned it previously, NavOps Launch, is a tool that we built out of our own necessity. So we have customers who have really large grid engine clusters, and they run ridiculous amounts of jobs on them. As an example, in the AWS booth, we're working with them to do like a 1 million core demonstration of actually running a containerized workload on about 58,000 instances. Well, you don't really have access to that type of infrastructure to do that type of testing. It's just, you know, it's not lying around. It's a lot of money. So we created this tool called NavOps Launch that allows us to quickly build these infrastructures. You can use them and you can tear them down. You can make them dynamic. And it's pretty straightforward. I mean, the diagram is sort of an architecture. It has plugins to plug into the common cloud providers. So you can actually create infrastructure across these different providers. And one of the real valuable things there is that you're not really tied into one vendor. You can pick one. You can even create your own OpenStack if you want and use that as well. And underneath, the configuration management is done by Puppet. And a lot of people get a little bit of a hiccup around that. They're like, Puppet? Man, I don't know how to use Puppet. I use Chef, or I use Ansible, or I use SaltStack. Well, we have done a fair amount of effort making sure that, you know, your stuff can run first on the nodes, configure all they need, or last, the order doesn't matter. We'll run our stuff that we need to get done, and then your stuff takes over. So it's not like it's, you know, you must use Puppet. It's like, use it alongside what you already have. And it's deeply integrated into Grid Engine, Univa Grid Engine. In fact, again, one of the unique values of this is that it pulls data metrics directly out of Grid Engine. So you're making decisions not on, you know, hey, my CPU's at 5% utilization. You're making decisions that 4 of these types of jobs arrived in the queue, something like that. Next slide, please. And this is the goal where our customers want to get to. When we talk to them, they start off here, and they're like, hey, I just want to do it in the cloud. But usually after a few conversations, like, well, I really want to go and do the whole thing. I want to do the full hybrid cloud. And that's because they already have invested in this infrastructure on-premise. They're not going to throw it away. That's a lot of money. But they want to, you know, they want to basically buy for the average load and get the peaks based on cloud. I mean, it's a pretty standard, you know, economic thing that I think everybody who talks about cloud has said that's one of the reasons why you do it. What we do is we do the launch part, which talks to the cloud infrastructure and creates these nodes and does the configuration management, wires it all up, adds it to the cluster so that it works properly. We do not do the storage. I'll talk about that in a second. And from the end user's perspective, one of the nice advantages is there's no workflow change. I mean, they don't even notice that it added stuff in the cloud to run their work. They just still continue to put their work into Grid Engine the way they did before, except the system decides, oh, I'm going to run it on AWS, or I'm going to run it on Google, or I'll run it on Azure. Now finally, on the cloud storage side, you have to work with the cloud vendor. Cloud vendors have different storage technologies. If you can really pull it off, you should put it into object storage because that's going to scale the most for you. If you can't because you're stuck on some sort of file-based storage like an NFS, then there are various solutions to do that. You could use like NetApp has an ONTAP in the cloud. There are distributed parallel cloud vendors like Weka. You could do Lustre if you really want to, but it's a lot of work. And you could do Elastifile. If you're doing Azure, you could use Avere. So there's many different solutions, and we integrate with those. Finally, this is the part that your IT people have to be comfortable with. So they have to be able to set up the network infrastructure to make this transparent. Otherwise, it doesn't work. This is the first thing we have to set up, and then everything else sort of follows. Next. So I mentioned we did this million core demo, and I'll just talk one slide about it because it's pretty interesting. This is just one run. We've actually done it about 5 or 6 times now. We just didn't tell anybody. But one of the really interesting things about this in AWS is they basically have about 1.1, 1.2 million virtual cores sitting around doing nothing, right? So they actually have a spare capacity of 1.1 million cores in one AWS region. So we use them, and we did this with Spot Fleets because there's really no other way to build this type of cluster. When we first did it, it took about 2.5 hours, but by the time we optimize things, now it takes us about 1 hour and 15 minutes. So in 1 hour and 15 minutes, you can go from no cluster to 1 million virtual cores, and then you can run stuff on it. In fact, you could easily run over 1 million jobs on it, right? Just queue them all up. It starts farming them up. And I think Amazon has mentioned this, others have mentioned this. This comes down to basically time to whatever your solution is. Is the time more important, right? Then you use that money, on a big cluster like this and get the time reduced dramatically. For a customer who is looking at using this, they've gone from, I think it was 6 days down to 6 hours on this solution. So 6 hours is like you can do it every day if you really wanted to. So it's pretty dramatic. And this is not your standard garden variety grid engine. We had to modify this quite extensively to make it work and scale like this. In fact, we could probably create a paper that explains what we had to do to really make it scale to this kind of number. Because it's the original architecture of grid engine was not designed to do this. So, next slide. A little bit about some customers who are using Launch. So I think if you've been to some of our presentations before, Wharton talks about this. Really, the motivation for why they went to cloud is they had scientists who wanted to use GPUs. And he used to have GPUs in his cluster, but nobody used them for like 3 or 4 years. And then all of a sudden, everybody's like, hey, GPUs, I want to use it. And he's like, oops, I don't have them now. I got rid of them. So he had to do a cost-benefit analysis. Should I buy more GPUs, or should I try it in the cloud? It did cost them more to use in the cloud, but he doesn't need it all the time. That's one thing. And then the second thing was, he also did his calculation and figured out that, when Amazon comes out with the new ones, the P100s and others, I get to use those, and I don't have to buy new ones. So for his particular model, it fit. So it was pretty seamless. This was a hybrid cloud. Want to go to the next one? I think there's one more of them. All right. And this is Mellanox, a different, same kind of thing, hybrid cloud. But they wanted to do regression runs, things like that. Similar type of value. They're buying their hardware on their cluster for normal load, not peak load. Peak load goes to the cloud. I'm running out of time, so I'm going to speed up. Yeah, we'll stop after this one. So, with those hybrid clouds, how did we decide when things go to the cloud and when do they not go to the cloud? Well, it's based on policy that you define inside NavOps Launch, where you sit down. What we created was an automation engine where you have if this, then that. So you can write in a JSON, if this, do this, if that, do that, that type of thing. loaded into the automation engine, you can chain them together so you can create complex automation applets, very much like if this then that. And these things trigger and change the infrastructure based on your needs. So one of the most common things is like it has here, which is if somebody submitted a job and said Tortuga, then add nodes in the cloud. So you can make it as simple as that, just a label, or you can make it as complex as a particular group of people, particular job class. Pretty much anything could trigger the action of doing stuff. And you can have it trigger and add things in AWS or add things in Google, wherever. So that's how you build out sort of the business logic part of it, the part that makes the decision. All right, I'm going to stop here because I've pretty much run out of time. And I thank all of you for.
All right, let's give
attending.
William a big hand.